Oxygen Blast technical seminars are an Intertech production. For instructor-led .NET, Java, and XML courses, visit us at www.intertech.com.
As I mentioned earlier, the curly brackets are used really to designate the beginning and the end of a code block. So you've written this Hello World program, and now you're ready to get to run it. But before you do that, you're going to need to compile it into bytecode. And the way that you do that is you use a program that's found in your JDK's bin directory, and that's called javac. That's your Java compiler. Now you could call it simply by opening up a command prompt and typing in the command you see here, where I'm typing the fully qualified path to javac, and then I type in the full path of where my source file is located. Typically, though, what people will do is they will add that JDK bin directory to the path of their operating system. And once you do that, all you have to do is type javac and then the name of your class. Now, unfortunately, there are several things that can go wrong with your first compile. Let's say you didn't set up your path correctly. In that case, javac wouldn't be found. So you would need to fix that on your particular OS. Or, which happens quite a bit, you might have mistyped some of the Java file. Here's two common Java syntax mistakes with your main method. So, for example, I have an error message here that says hello world.java:4. That's telling me there's a problem in the hello world class on line number 4. Next is a message telling me what's going on. There's an undefined variable or class name called out. It then prints out a line of code and uses a little caret to kind of show you where it thinks the problem is. So here I can see, oh, you know what I forgot was system.out.println. How did I know that I should use system? We're going to cover a lot of that coming up when we take a look at Java docs and the API. But for now, just know that if I want to print a line out to the console, I use system.out.println and then whatever text it is that I want to print out. So that's the first error that I could see and fix. The second one here, you'll notice it says hello world.java, but it's a lowercase h. And then it says public class hello world with a capital letter H must be defined in a file called hello world.java. So remember, this is a case-sensitive language. The name of your class must match the name of the file that you save. As you learn and practice coding Java, compiler errors become easier to read. So let's say now we get past these compiler errors and we run javac. What's it going to produce for us? It's going to produce our bytecode. And what you'll notice is that it's the same name of the public class. However, instead of a .java extension, it'll now have a .class extension. This is what you're going to be distributing so that people can run your programs. If you happen to open up that class file in a text editor, you might see something like this. It's unreadable, primarily unreadable. It's definitely uneditable. If you try to edit this, you'd run into some serious problems. It's because this is binary data. It's been compiled into binary bytecode, which the Java virtual machine knows how to read. So this is what you distribute as a program. It's not what you edit. Instead, you edit the .java files. So remember, a bytecode file contains machine code for the JVM. Although it's not exactly machine code, it's also not simple text. All right, so we're almost there. We've written our source code. We've compiled our source code into bytecode. Now we want to run that bytecode. And the way you do that is, again, from a program that's inside of your bin directory called Java. Java really is your JVM. That's the container that's going to run your programs. So you write Java and then the name of the class. You'll notice that you don't write the suffix .class. I don't write Java hello world.class. I simply write Java hello world. And it should run the program. Now, if everything worked perfectly, this is what you would see. And look at our command prompt here. I type javac hello world.java, enter. No messages. Oftentimes in Java, no news is good news. If there were any problems with the compile, it would tell me at this point. But since it just came back with another directory prompt, I know that everything went well. So here now I'm ready to run the program. Java hello world. There it prints out the text, hello world, and the program ends. It's not quite exciting to look at, but if you look at what's going on behind the scenes, quite a bit is happening. So let's revisit that JVM and see what's really going on behind the scenes. When you start that Java executable from the bin directory, you're really firing up the Java virtual machine. This is the tool that makes the Java platform independent. Every operating system you use will have its own version of the JVM. So when you run it, what it's going to do is it's going to say, okay, let's see, do I have this hello world file in memory already? No, I don't. Let's see if I can find it. So it's going to look in certain places to see if it can find that .class file. And it will load it into memory. Now, it's going to verify that bytecode before it does anything else with it. And so if anyone tried to change the bytecode in some sort of a way that it became a, say, malicious program that was accessing areas of memory it has no business accessing, well, that kind of security is going to be caught. That kind of issue is going to be caught by the bytecode verifier, and it wouldn't let it continue. But once the bytecode verifier says, nope, everything looks pretty okay to me, then it's going to interpret that bytecode for the underlying operating system. This is where the Java Hotspot technology that I mentioned would come in. It's going to be responsible for selectively interpreting different parts of the code when it thinks it's appropriate to interpret the code. This is all about performance. So that's the basics of how you write and run your first Java application. Next thing to know is, well, there's some APIs out there, right? I saw system.out.println. How do I learn how to use this? How do I learn more about the different libraries that are available? The way that you do this is through Java API documentation. Really, memorizing the entire Java API is very, very hard, if not impossible. What you'll find over time is that there's a chunk of stuff that you'll be using over and over again that you'll commit to memory. The rest of it, you're going to want to be able to look at some documentation. So the best place to get started with the API is with an index.html file that's found in the docs folder under the JDK. This is your Java documentation. It's better known as Java docs. The docs folder under the JDK is its conventional location. However, you can grab that folder, that directory, and put those files anywhere that you want. Oftentimes what I'll do is simply look up the Java documentation online. And here's a URL of where you could find that Java doc online. Because you will use Java docs often, it's usually a really good idea to bookmark that particular link. As you're going to be doing the labs in this class, keep that in mind because you're going to want to reference the API frequently throughout this course. So remember, Java is way too big to cover in 5 days, so this is a resource that's very important for you to learn how to use. Let's take a look at some Java docs. When you open up a browser and you open up that index.html file, this is what you'll see. Now, it's not pretty. It's using old frames. This is a format that's been around for quite a long time, but it's extremely handy. Let's look at each of the different frames and what they contain. Now, the panel on the upper left is going to list all of your packages. We'll discuss packages later in this class, but just think of it as a folder, a directory for right now. So different areas of the API are broken down into different packages. Now, if I click on one of those packages, that's going to change the list of classes, which is right underneath. It's the frame underneath. So now I'll see all the different classes that are available to me for that particular package. So scrolling through this list can become either overwhelming or encouraging. So the good news is, wow, a lot of people have written a lot of stuff that I can use. And of course, the bad news is, wow, a lot of people have written a lot of stuff that I can use, but also have to learn. But again, that's where these Java docs come into play. So if I click on one of those classes, then it's going to change what you see in the right panel. The right panel is your main panel. So if I clicked on File, for example, I would see what you're seeing on your screen right now. It'll tell me a little bit about that particular class. It'll tell me about its inheritance, any implemented interfaces. Again, all these are terms that we're going to define throughout this course. You'll see here I get a little bit of information of the purpose of the class, how it should be used. Now, although the Java doc doesn't contain its own search functionality. You certainly could use the browser search or any other kind of tool that's on your operating system to find different things in this file. I often just use a search engine to be able to find the exact location I need and look at the API documentation over the web. In addition, there's some links that are at the top of the main page. For example, they're showing here an index, which would be an alphabetical link to all of the resources. So that's all of your classes, your methods, and more. All right, so that concludes our first chapter as your introduction to Java. This next slide contains some resources that are available for you for further exploration on this topic.
For more free learning resources and to see the latest lineup of our instructor-led .NET, Java, and XML courses, visit us at www.intertech.com.